Good day, everybody. My name is Larry Schofield, and it's with great pleasure that I have the opportunity to introduce Dr. Michael Darter. He's an international authority in repair, preservation, rehabilitation, evaluation, construction, and design of concrete pavements. Through his consulting, research, and teaching work over the past 50 years, he has contributed significant new knowledge and many best practice guidelines, specifications, training courses, and engineering tools for concrete repair and preservation. He will be presenting on the long-term performance of rapid strength concrete slabs on California highways. And with no further ado, I'll turn it over to Dr. Darter.
Thanks for the introduction, Larry. It's indeed a pleasure to be here today with all of you. I'm sure I know many of you, smiles on your faces, to talk about pavement performance, which is one of my favorite subjects. And today we're going to focus on the rapid strength concrete slabs that are placed on California highways. The Caltrans has used rapid strength concrete repair since at least the 1990s. The RSC, as I'll use the abbreviation, is required to reach, of course, a certain strength within a very few hours. And this capability allows for an opportunity for overnight pavement replacement. Lanes are closed about 11 p.m. The existing slabs, cracked slabs are removed. The base course is repaired, sometimes replaced. Dowel bars and interlayers are placed. The RSC is placed and cured. And finally, after you gain the strength, the lanes are open, typically around 5 o'clock the following morning. This has been a very successful practice to reduce the amount of congestion and repair and keep concrete pavement and extend its life in California and many other places. Big question is, how are these slab replacements performing? Well, Caltrans conducted a study in 2008 that was titled Evaluation of Rapid Strength Concrete Repairs. And this documented the short-term performance of RSC. And you see the authors on here. This report is on the Caltrans website. It's an excellent report. They picked up 15 projects in 6 regions on major freeways and surveyed over 5,000 RSC slabs and recorded all the distresses that they could see. These projects, again, was average just 3 years of age, but they found very, very few transverse longitudinal corner cracks, joint spalling, shrinkage cracks, or anything else like faulting. None of that. And their conclusion is only about 1.4%. That's like 1 out of 100 slabs surveyed showed any of these, what they call premature distresses. So that's really impressive. But what about the longer term, of course? These repairs now are around 13 years as of 2018, and they've been under some very heavy truck traffic. How are they performing? Just the photo on this slide just shows where a couple of slabs in the outer truck lane have been replaced. You can even see transverse cracks in the next lane over, which is the original pavement placed probably 30, 40 years ago. To do this study on longevity, there's 2 different Caltrans applications, RSC applications. Individual RSC slab replacement is the first. Cracked or badly damaged jointed plain concrete slabs are removed and along a traffic lane and replaced with RSC. The slab thickness, the joint spacings on these projects remained the same, and most of these were all 8 and 9 inches, probably mostly 8. And they had the random sequence of joints, 12, 13, 18, and 19. The existing base courses were left in place, and dowels may or may not have been used. We think they were used on most of the projects that that were surveyed in this study and in what we did. This is the spec, Caltrans specification for that application. Number 2 is what we can call lane replacement RSC. Here, all the slabs, the base course along a traffic lane or 2 traffic lanes are removed and replaced. The slab thickness is designed and typically comes out thicker, like 10, 11, 12, 13 inches, 14. Perpendicular dowel joints is much shorter at about 14 feet uniformly, and you have a new base course is removed and replaced. But this specification is shown right here. So let's first take the first application, the individual RSC slab replacements. We identified 6 individual projects that were randomly selected by Caltrans from a long list, but it was actually from the original 15. So we're continuing the survey on 6 of those projects. Each of these has a length of 1 mile to 2, 3 or more from the same study published in 2008. A total of 12 traffic lanes were surveyed, and that included inner and outer, and almost 1,500 RSC slabs located on these projects. The latest data from Caltrans 2018 video monitoring films were used to identify the distresses. Here is just a matrix. You don't need to read all these numbers. Just look at the yellow line. You can just see several of these projects on I-10 and I-5 and so forth. The one I just showed the picture of is San Bernardino. Thin slab built in the 1970s, and now in 2005 was the RSC individual slabs. So about 13 years. And in the inner lane, it's carried 12 million trucks. In the outer lane, very heavy truck traffic, 28 million. The manufacturer of the cement is either CTS or 4x4. Those are the 2 most prevalent that we found in California. So we'll be looking at these 6 projects first. CTS was used on 864 slabs, and 4x4 was one large project of 629. And again, as I mentioned, we will look at both inner and outer lane, and you'll see some amazing differences. The distresses that we identified was very much identical to what they found in 2008. Transverse cracking, longitudinal corner cracking, and joints falling. Really didn't see hardly any. There was just a minor amount of shrinkage even in 2008. In addition, we went out a year later on these projects and did a field visual, you might call it a validation, to make sure that what we saw in videos, that there wasn't anything else, that kind of an aspect. Okay, a quick word here on the RSC slab materials. First of all, CTS is a rapid set cement, a Beltic, just call it CSA cement, made by the CTS Manufacturing Corporation. And we're thankful for them for providing the support for this long-term study. This is a non-proprietary technology produced in a cement plant. Rapid strength gain, opening strength is the Caltrans requirement of 400. Flexural strength in about 4 hours, actually. This achieves it much earlier than that normally. Very low shrinkage, high sulfate resistant, ASR resistant, and can be used in a volumetric mixer or a transit mixer. And it can cure compounds such as PAMS or even water cure can be used until strength is achieved. This has been around a long time, and there's lots of excellent articles, particularly Professor Bisher from UCLA. 4x4 was the other one, and that interesting title comes from the Caltrans 400 PSI within 4 hours, the specification. This is a Portland cement, a retarder, an accelerator, a super plasticizer, BASF Master Builders involved in that. It's a patented technology offered by multiple admixture suppliers, rapid strength gain, opening strength, again, at least 400 in 4 hours. It can be higher shrinkage if a shrinkage reducing admixture is not used, and it's type 3 cement. I've been told it cannot be used in a volumetric mix, or transit mix only. And this is well defined more in the original report, shown right here, and on the internet, of course. Okay, let's look at the results here. Here's the 13-year study from 1,493 slabs. Percent slabs on the vertical axis there, and you can see out of all those distresses, the only one that matters, that showed anything, is about 9% of the slabs showed some transverse cracking. But as far as the other kinds of cracking, virtually nothing. So what is this transverse cracking? Well, this is just the well-known fatigue cracking that we try to prevent in pavement design. We design for this with an adequate thickness and joint spacing and support to prevent it from happening. Just to give you a little better view of the cause of that, you see that truck loading the slab, where most slabs are curled up. Well, that produces a high stress in the top of the slab. Well, multiply that times millions and millions of heavy repetitions. It works its micro crack starts across the slab, down through the slab, and creates eventually a crack that can break down. It can lead to more other kinds of cracking. So it's the kind of thing you want to, minimize in design, so you get long life pavement. Well, this particular survey showed that in 08 there was 0.8% of the slabs. 10 years later, there's 8.8 over the 13 years. But where are they occurring? Here's what's interesting. Look down here, outer lane transverse cracking, 21%. That's 1 out of 5 slabs have developed this cracking. But this outer lane has carried, at least 20 million. This is the average. It even went up higher than that on some of these projects. The inner lane at the same time only cracked 3%, 1/7, but carried still 6 million trucks. So it's obvious it's a fatigue related phenomenon. It's a thin slab, 8 to 9 inches, and long slabs. These were the predominant cracks were in the 18 to 19 foot sequence of random slab joint spacing. So it's no surprise at all, and it's what one would expect. So that's the structural aspect. Now the durability, such as decracking, freeze thaw, not a freeze thaw area, but anyway, shrinkage cracking, ASR, we didn't see almost any of that over any of these 6 projects. And they didn't either on the where they had the 15 project in 08. So it's really good durable concrete out there in these RSC slabs. There are reports, and I read one in an excellent report that's on the website that talks about a project that had durability issues where the surface became somewhat pitted and shrinkage. It was basically blamed on construction quality and variability in construction quality. So obviously, you're out there in nighttime and you've got a product that has to be placed immediately. They set up within, 20 minutes or so. So you got to have your act together out there in the field and do this right every time, every night. And so that's what's important. But I think the fact that almost none of these slabs or projects showed any of this kind of distress really shows the value of this particular and the quality that is getting done out in California on these projects. So let's look at the 4x4 versus the CTS. This is the first project here is the carried as 4x4, 3 million truck traffic, percentage of inner lane fatigue was 0.1. The inner lane longitudinal, you can see, is almost 0. So very small amount of cracking. And for the CTS, 5 different projects exist here. And it had a heavier truck traffic. That's the difference. So it's not a fair comparison. And you can see the consequence of that is a little bit more fatigue cracking. And you've got 0.07 and almost 0 amounts of other distresses. So I concluded, based on this data, there's really no difference here. Both of these products are performing very well and giving excellent performance over 13 or 14 years. We went out and did field surveys on 5 of these projects, as you can see, and there was no surprises out there in the field, so that was good news. So good durability, and aside from the structural fatigue problem, these projects are performing very well. And we'll talk more about that in a moment. But now, let me just show you a couple of photographs. This shows CTS application, a couple of slab replacements here. This shows a close-up of the CTS surface. You can see it's been diamond ground And these were pretty smooth projects, even after, 10 years, 13 years of service. Good lower noise and very smooth and good friction, obviously, on these projects. So all of these were diamond ground, basically. And we think that's an excellent recommendation. Okay, now let's go to the second type of application, and we call that lane replacement RSC. Here is Interstate 10 in Riverside, California, built in 03. This is in one of the original slabs, the second lane over, built in the 1980s with longer joint spacing, 9 inches. And the outer lane was replaced. It had cracked fatigue so badly that it was replaced with RSC in 03. 11 inches thick, 14-foot joint spacings and dowels in every joint, and new base course also. And this lane has virtually, over the last 17 years, has virtually no fatigue cracking, no transfers, no longitudinal, no anything, basically. Excellent performance. Okay, we picked 6 of these projects from a long list of candidates. These were all in the outside lane, so note that here. Whereas prior, the individuals, some of those were in inner lane, some were in outer lane. But these are all in the heavy truck lane. There just weren't any replacements, complete replacements done in the inner lanes for obvious reasons. There was not enough cracking. This included a total of around 2,000 slabs. And we used, again, the latest version of the Caltrans Google Maps. And the distresses that we found were basically identical to what we found on the individual slabs. Transverse cracking, some longitudinal, some corners, some joint, and so a little bit of shrinkage cracking. Here is the slab, the projects, the 6, each row here is an individual section. You can see I-15, I-10, I-5 all the way down. And the yellow one is the one I just showed you. We're not quite sure what the RSC manufacturer is on that, but it was the oldest and heaviest traffic. So we just definitely wanted to include that one. Okay, here's the results now from 2,000 slabs. And what's most interesting, transverse cracks, 0.3%. That's a very, very small number right there of fatigue cracking. And as you scan down, you see almost no longitudinal corners, falls, shrinkage, very little, all less than 1%. So that's really, really good. Let's dig into that just a little deeper. Well, let's just comment. Let me just say, for durability, these are 9 to 17 years of service, and almost very few of these are showing any kind of durability issue. So that's, an evidence, again, that good construction quality is going on these California projects in general. And yes, there may be a couple projects out of many, many that have been built that do have some issues. But that's kind of normal, I think, with any product. So let's now look at the comparison of these, of the CTS versus the 4x4 concrete mixtures. Scan down these. Here you see, very low amounts. And when you can make these comparisons, it's very, very close. The only one that shows any significance at all with this 1.8, this was a little bit of pitting on one section along a few slabs, but no maintenance had been done on this, on these RSCs, so it was not that big of a deal. And it was very limited in the first place. Okay, so I conclude that, this is excellent performance. We're talking 9 to 17 years here on very heavy traffic, outer truck lanes. Very good performance. Let me just show you a couple of photos. I'm sorry, the photo's not that great. It's my camera on the computer screen. But as you can see, here's the CTS project in LA County, Interstate 5, 10.7 inches thickness, 14-foot joint spacing, and a new base course. Virtually zero problems after 10 years of service. Here's another one on California 60. Again, the outer lane was the lane surveyed. This was only 9 inches, but it was 14 feet joint spacing with dowel bars. And you can just see that has a dramatic effect. This still has carried at least 10 or 15 million easels, not easels, but trucks. I mean, sorry, heavy trucks. Here's another section. This is I-10 at Riverside County, built in 08. So this is 12 years old. This is a 4x4 section, 12-inch thick, 14-foot joint spacing, and virtually no distresses at all. So let's now put these two applications together, the individual RSC slabs and the lane replacement. The age and the trucks on these projects, as you average them across the 6 projects on each one, are almost the same, 13 years, 12 years, 20 million, 16 million. But here's the difference. The only difference is that in the individual thin slabs, longer joint spacings, 21%. There's that 21% again, versus 0.3 or practically 0. So there's no fatigue damage going on where we have the thicker slabs and the shorter joint spacing. Look down all these other distress types. You see virtually the same, which is virtually low, all below about 1%, all the way down. So that is, and we're talking heavy traffic outer truck lanes here, not the inner lanes. So I put together, for what it's worth, just a very simple table for longevity based on the data that we found and surveyed. So if we look at just the outer lane first here, the individual RSC, so that's the thin slab long joint. You know, around 10, 13 years, that's about the life you're going to get when you put that kind of thin pavement down. If you go to the inner lane with much heavier, you know, truck traffic, much heavier, 3-4 times heavier, you're going to get at least in the inner lane, I mean lower, it's on the inner lane, you know, at least 15 years, 20 years, who knows, beyond that probably. Now, with lane replacement, where you're designing the slab, you're putting shorter joints, you're dowel barring every joint, a new base course, at least 20 years. None of these are showing anywhere close to a problem. So 20 is very conservative number. It's probably more than 30. But in the inner lane, of course, you're going to get a very, very, very long life. So for what it's worth, that's just my estimate. And now just 3 recommendations here for the individual slab replacement. Lower truck traffic, you know, in any of the inner or medium lanes, this will work very well. If you want to put it in the outer lane, though, even with the thin slabs, you can still get up to 10 years or so of pretty good service, you know, on a short-term strategy, you might call it. Use of dowel bars at all the joints are highly recommended to prevent faulting, and diamond grinding to give good smoothness and low noise, good friction is highly recommended. For the lane replacement, you know, that can handle any level of truck traffic, and it can be designed to cover that in terms of thickness and joint spacing and dowel bars. It clearly solves the fatigue cracking problem and dowel joints to prevent faulting on every project. Diamond grinding, again, gives you that long-term smoothness. One other thing is that I think that good durability criteria must be required for all these applications, for shrinkage, for ASR. In the past, you know, this has been thought of as, at least the individual slab replacement, as short-term, like less than 5 years. And maybe we don't need, you know, some of these durability criteria, but I really think you do, because they're going to last long more than 5 years. And that's certainly what the data shows. So that's it. That gives you a kind of a summary. A good final report is coming out very shortly. I want to thank the CTS Corporation for providing some funding for these long-term surveys, and also thank Caltrans sincerely for helping locate these projects and selecting some video files, field validation. is gratefully acknowledged. So thank you very much.
Great presentation, Dr. Darter. Really appreciate it and learned it a lot. You did a really good job about explaining why the single slab replacements, because they were thinner, didn't have the service life of the lane replacements. So the question I had is, you recommended different locations, but do you think by designing and placing the individual slab replacements to the required thickness would increase their service life as well? Do you really think that's practical?
Well, if it could even be increased by 1 inch, now I'm talking in the range of like 8 inches going to 9, 9 to going to 10, 10 to 11 perhaps. Yes, that would definitely have a big improvement. There's no question. And the only difficulty is the base course. If it's an unbound base course, no problem. You can remove aggregate easily. However, if it's stabilized, you might not be able to remove much, but if you could, it would certainly be helpful. Thickness is certainly a key variable, but if you can't do that and you just simply can add a joint in between, especially if the old or the existing pavement has long joint spacings, much longer than 15 feet, and you can just put an extra joint in there. That would reduce, but you have to dowel bar and as well as the adjacent joints. That would go a long ways to expanding the fatigue life, the structural capacity of that pavement, Larry.
Thank you very much. And the last question is, what do you see as the future use of the RSC technologies in concrete pavement preservation?
Well, I think as long as traffic congestion is going to exist, this is going to have a big role to play. And, by going at night like Caltrans has done, they really do avoid a tremendous amount of of congestion and safety issues that exist, and they've been performing exceptionally well. This is a technique that extends the life of the pavement. There's just no doubt. Other states that I've done survivability in shows that pavement restoration, all the techniques now, not just slab replacement, but the diamond grinding, the dowel bar retrofit, and so on, can double the pavement life, can double it. Take it from 15 to 30 or 40 or 20 to 40 or 50 years. So that's a very cost-effective, in any analysis, cost-effective solution. So I think people just have to have confidence that rapid strength concrete will perform, that it will not cause, be durability issues or fatigue issues. They need confidence. It will be reliable, and I think it will be used more and more. And that's why we need more studies of what is going on out in the field, not what some people's imagination of what's going out there. What are the real data? What do they show? And I think that this is one example that shows pretty darn good performance and reliable performance.
Excellent. And once again, thank you very much for your time and effort. We greatly appreciated it.
You bet. It was a pleasure to be there.